All right, we've already talked about the pseudocode for our quicksort algorithm, which essentially does something like this. It takes an integer array, it takes a low index and a high index to determine the size of this thing, and then it's basically saying if it hasn't converged yet, then it does a partitioning based around a pivot point. And then it quicksorts the right side, and then it quicksorts the left side. Now, the hardest part about this entire function, obviously, is this partition function. So let's take a look at, in more detail, what this partition function should do. So the partition function here is going to take a array, again, and then it's also going to take a low index and a high index, right? Now, it's the job of this partitioning function to pick the pivot and then put it in the proper position, and then everything on the left side should be less than it, everything on the right side should be greater. So, for example, if we use this array over here, 3, 6, 5, 1, 2, 4, it's the job of this partitioning function to select a pivot. In this case, we're going to use the logic of selecting the final element or the last element in our array as the pivot, and then moving it to its proper position, and then having everything greater be on the right side, everything smaller be on the left side. So in this case, it's the job of this partition function to return back an array that looks something like this: 3, 1, 2, 4, 6, 5. Right? Now, interesting thing here is the pivot value is in the proper sorted position for this overall array, which is the beauty of quicksort, right? Is that the sorting of it actually happens as it's doing the partitioning, as opposed to when it's being merged back together, like in merge sort. Now, the numbers here on the right side, it does not matter what the order is in, as long as they're all higher than our pivot element. The numbers here on the left side, it doesn't matter what order they're in, as long as they're all lower than our pivot element. Right? So let's take a look at how this function operates. And I'm going to talk about, now there's many different ways to do this. I'm going to talk about my favorite way to implement quicksort. So my favorite way to implement quicksort is you take a look at your pivot element here, 4. And then what we're going to do is we're going to loop through, this is sort of just a regular loop. Well, I is equal to low. Well, I is less than the position of our pivot. We are going to loop through this, moving our way through the array, and every time we encounter an element that is higher, so like our 6 here, we are going to move it to the right side of the 4, right? So let's take a look at what that would look like. First, we would look at the value 3. 3 is less than 4, which means it's good. It's on the left side of our pivot element. There's nothing we need to do here. Then our index goes up by 1. We look at the value 6 here. 6 is on the wrong side of the 4, so we need to swap it. Now, there's no room on the right side of the 4 here, so we need to make room for it. So there's a couple of things we need to do. The first is we move the 4 to the left by 1, which makes room for the 6. Then we take the 6 and we move it up here to where the 4 was, where our pivot element was. And then we take this 2 and we kick it back down here to where our 6 previously was. This is one of the many ways to do it, and in my opinion, it's my favorite way. So, what does that end up looking like? Well, we encountered this number that was greater, and we're going to kind of do this three-way swap here. So the 2 ends up being where the 6 is. Then we have a 5, a 1. Our 4, our pivot element, got moved down to this position, and then a 6 was properly moved to the right side of our pivot, right? Which is great. Now our index here, we're currently looking at the second element. We're looping through this thing, and we're looking at the second element. Because we did this three-way swap, we moved a new element into that position, so we don't increment this index here. So we continue looking at this one. So 2, is 2 less than our pivot? Yes. It means that it's on the proper side of the 4, it's on the left side, we don't need to move it, right? So we increment our index. 5 is on the wrong side of the 4, which means that we need to move it to the right side. So, very similar to what we did before. We're going to move the 4 to the left by 1. We're going to take the 1 and we're going to move it into the 5 position. And then we're going to take the 5 and move it into the 4 position, which means that we end up with something like this. 3, 2, 1, 4, 5, 6, right? Perfect. Here's our 4. And our index, we're still looking at this index here, where we moved the 1 into. And then finally, because these things are right next to each other, we don't need to do a three-way swap anymore. Now we can just ask ourselves, is 1 less than 4? If it is, we're good. If the 1 was greater than the 4, the last thing we do is we'd sort of just swap these two elements, right? So there is a small case here that says if these two are right next to each other, and we're going to swap them, right? And then once our index that we're looping through is greater than or equal to the position of our pivot, we're done, right? So to start this entire thing off, the first thing we need to do is we need to select our pivot. And we're going to say that our pivot is equal to a brackets high, right? We're going to select the element that's at the very end of this thing. Then we're going to have a loop here for int I is equal to 0. Well, I is less than the pivot index, right? And our pivot index needs to be initialized to something, right? It's currently in the high index, right? So we initialize this thing to high, and then we say I plus plus, right? But remember that this is only going to happen sometimes. This should only happen if our element has not been swapped, right? So you can either leave this here, and then you can have a I minus minus, a decrement, whenever you do a swap, or you can leave this out and just do something like this, where you're like, if a bracket I is less than the pivot, then you're good. There's nothing you need to do here. In the case where the element, like ours 3 here, is less than the pivot, all you need to do is increment I. Else, this is the case where you need to do the three-way swap, right? And remember, we're doing a three-way swap. There is this small case when they're right next to each other that you just do a two-way swap. Just swap these if you need to at the very end. And other than that, you're done. This is the partition element, right? And the really great thing about quicksort is the fact that it's sorting this stuff as it's going through.